Hey everyone, we're going to prove Theorem 6.4, the triangle proportionality theorem. So we're given that these two lines are parallel, and we need to prove the theorem that QT divided by TR equals SU divided by UR, and that's the theorem. So the first thing we're going to write is the given, which is that QS line segment is parallel to TU, the line segment TU. Now, it helps us out here. Angle S is congruent to angle TUR. Now, that's because of the parallel lines, and we have these corner angles. Well, that's corresponding angles theorem. So I'm going to write that up here. Corresponding angles theorem. All right. And then we have another corresponding angles theorem. And so that would be that angle Q is congruent to angle UTR. So let's look at that. Angle Q is congruent to UTR, this one. Again, due to your corresponding angles theorem. So our triangles are similar. So I'm going to erase this, and it's saying triangle SRQ. Where's S? SRQ is similar to triangle UTR, this smaller one. So you could kind of pull them out. And that's because we have these two congruent angles here. So that's by your angle, similarity, postulate. Therefore, by definition of similarity, so this is definition of similarity, QR divided by TR. So I'm going to erase this again. QR divided by TR is similar or is equal to SR divided by the smaller side, because we have the smaller triangles. So that's going to be UR. So they're just similar. And again, it's because these angles here are congruent. And it's by the angle one. So now let's look at number 6. So for number 6, we have QR equals UT plus TR. And let's look at it over here. Whoops, sorry. QR equals let's look at it here. QR equals these two added together. And SR equals these two added together. So that's just your segment addition postulate. So that's segment addition postulate. And we have that QT plus TR divided by SU plus UR divided by UR. So that's your substitution property. And that's because we have this. So QR equals QT plus TR. So when you have QR divided by TR, what I'm doing is I'm substituting this for my QR. So I'm writing QT instead. QT plus TR. And then I'm putting the TR. And for the second one, the same thing. We're looking at that. And so let's write that down. SR divided by UR. But SR equals SU plus UR. So we're going to write it as SU plus UR divided by UR. Now, so the two we have are these two. It looks better if you write it like this. Well, based off our proportionality, our true proportions, this is also QT divided by TR, and that's going to be equals SU divided by UR. And that's your simplifying of your proportions. And I'll show you why for this last step in the next slide. So right here, when you have proportion properties, most of y'all know that you can just do the reciprocal, just reciprocate both of these. Or you can interchange the means of the proportion. So, but what we did is this one. If you add the value of each ratio's denominator to its numerator, then you form another true proportion. So what we had on our last statement was this. So then I can write it this way. So I can take off the B here and the D here and get this part. So we went that way. We did, this is if P, then Q, and what we had is if Q, then P. And that's it. Thank you. Have a nice day. Bye-bye.